Okay, so when we left off yesterday, we were graphing equations like these. So let's take a look and see how you came out on them. So the first one up there, y equals 1/2 x minus 3. Where do we start on that? Remember, we start at the origin at the center here for all graphs, but then we have to move up or down. What tells us how far we move up or down? The -3. So from here we go down 3, and that's where we start, is right there. Now, how do we know what to do from there? We use the slope, and where do we find the slope? The slope is the number that multiplies the x, and it's always a fraction, a rise over run. Even if it's not a fraction, we make it a fraction. So here it's 1/2 that multiplies the x. The rise is 1, so we go up 1, and the run is 2, so we go over 2. There's our second point. Now those are kind of close together, so I'm going to do it again. Up 1, over 2. And I could keep going if I wanted to, but we get a nice straight line. Now, of course, the reason we were able to do this is because we looked at these equations and we knew from the form of the equation that they must form a line. So then we knew we could do just a y-intercept and a slope to find the line. The next one here, y equals 3x minus 5. Where do we start on that one? So from the origin, we go down 5 to -5. Now our slope here is 3. Now that's just a whole number, so we make it a fraction by making it 3 over 1. So from my starting point here, how much do I rise? 3. 1, 2, 3. And I run 1 right there. I'm going to do it one more time. 1, 2, 3, and then run 1. There's another point. And my line goes through those points. Any questions so far? How many of you got the first two right? How many would have? They just kind of forgot a little bit overnight. Okay, it all makes sense now? Third one here in green, y equals -3 over 2x plus 2. Where do I start there? From the origin, I go up 2. It's a plus 2, and my slope is -3/2, which means I go, what's my rise? 3. It's going to be negative. The negative always goes with the rise. So it's down 3, and then run 2, over 2, right there. We'll do it one more time again. 1, 2, 3, down, and over 2. Oops. Pretend I can draw a straight line today. Wow, that's bad. Okay, so then this fourth one here in purple. I rearranged this one a little bit, but it's all the same information that's there. Where do we start? The 2 is multiplying the x, so that's our slope. So that's our 2 over 1 we'll make. So it's the number that's added or subtracted would be the 4. It's a lot of times for me it's easier to find the slope first, and then I know the other number has to be where I start. The slope always multiplies the x. So I start at the 4. So from this middle, from the origin, I go up 1, 2, 3, 4. There's my starting point. And now my slope is 2 over 1. So up 2 over 1. I could do it again, but I'm out of room. Now, one thing I can do is 2 over 1 is the same as a -2 over -1, because a negative over divided by a negative is a positive. So if I wanted to, if I was out of room here, I could go down 2, back 1. Down 2 and back 1. And notice that gives me the same slope. I'm just reversing both of them to get an extra points to graph them. Okay. Next down here in red. What is different about that equation from the ones we have seen in the past? There's a 2 in front of the y. All of these are y equals, y equals, y equals. And in order to use this shortcut for graphing, it has to be y equals. It doesn't work if we have it any other way. So we're going to have to do something about that. So I'm going to rewrite this equation. 2y equals 3x minus 4. And just like solving any other equation, I look at that, I have to get rid of the 2. Well, how is the 2 being attached to my y? It's being multiplied. So I get rid of it by dividing. When I multiply or divide an equation, I have to multiply or divide the whole thing. Every piece on both sides. So if I divide here, the 2y is one thing. So when I divide by 2, it takes the 2 off. Over here, I not only have to divide the 3x, but I also have to divide the negative 4 by 2. So I divided out the 2 to leave me with y there. I have 3x divided by 2. Now there's a little trick to make that easier. Since we're not afraid of fractions anymore, 3 over 2 is just 3 over 2. Remember we talked about division and fractions being interchangeable? So we're going to change our division just into a fraction there, and it's all done. We also have the negative 4 divided by 2, which is negative 2. Any questions as to where that equation came from? So now we're going to start out at negative 2 right here. From the center, we went down 2. And our slope is, we're going to rise 3, run 2. Right there. Okay then, how about this equation? What's going on there that's not typical? What's different there that we haven't seen before? The minus 3, exactly. So what are we going to do about it? Add 3, exactly. We want y to be by itself. The 3 is keeping it from being by itself, and the 3 is subtracted. So to get rid of it, we add. Adding 3 makes it go away. Now when we add or subtract from an equation, we just have to do it from one piece on each side. Notice here I added 3, it just took out the minus 3, it didn't do anything to the y. We're left with the y. Over here, and the reason for this is when I add or subtract, I can only combine it with things that have the same name. So chances are there's only one thing on each side that has the same name that I can combine it with. So what on this right side here, what over here can I combine that adding 3 with? The negative 2, exactly. So the 1/2 x does not change. Negative 2 plus 3 is positive 1. So I can graph that. Where am I going to start? Positive 1, and from there I'm going to go up 1, run 2. Oops, I don't know why I went 3. Up 1, over 2. Up 1, over 2. There's our points. What do you think? Did anybody get those last two? Before I went over? Kind of? Sort of? Well, that's what we're going to progress here at first today. Is we're going to start with something like that. I want you to try graphing that in your notes and see what you come up with. Okay, so what do we have to do to alter this equation? We have to divide by 3. then we have to divide every piece by 3, every term, every digit. So 3y divided by 3 is just y. Now over here, it helps if I make that a 1x. 1x divided by 3 is 1/3 x. And then -6 divided by 3 is -2. So when I graph it, I start at -2. From there I go up 1 over 3. Try that one in your notes. Y plus 5 equals 3/4 x plus 2. Let's see what's going on with this one. What do we have to alter to graph this one? We have to get rid of the 5. And it's plus 5, so we're going to subtract it. So that makes it go away there, gives us y. Remember, when we add or subtract, we only have to do it to one piece on each side. So the 3/4 x is going to be left alone. We have 2 minus 5 is -3. So where do we start over here? -3, good. And from there we go up 3 over 4. Right there. Not so bad? Okay, well then let's keep going with that. Let's look at something like this. Graph that. What do we have to do first here? This is the first one we've encountered where there's actually two things that are keeping y from being by itself. But we're going to approach this just like we would solving any other equation. Only we're used to solving for x. This time we're solving for y. But we're still looking at finding the equal sign and identifying which side of the variable has the y on it. And that's over here. What's that? Okay, yeah, there's two things keeping it from being by itself. There's the 3 and the 2. The last thing that would have been done if we'd have built this would have been subtracting the 2. So that's the first thing we're going to get rid of, is adding the 2. So we add 2, it takes that away, leaving us with 3y. On the other side, do we have to add 2 to both pieces or just to one of them? Just to the 4. When we add or subtract, we only have to do it to one piece on each side. So the 2x is unchanged. Positive 4 plus 2 becomes positive 6. What's the next step? Divide by 3. When we divide or multiply, we have to do it to every piece on each side. So we divide this to cancel out the 3, gives us y. On this side, 2x has to be divided by 3, which will give us 2 over 3, or 2/3 x. And the 6 also has to be divided by 3 to give us 2. So we're going to start at 2, and from there we're going to go up 2 more and over 3. How many of you got that one? Good. Let's have you try one that's similar to that. Try that one. 2y plus 5 equals 4, must be 4x plus 1. Where do we start? We're going to subtract 5 to get rid of the 5. So 2y equals 4x. We have to do 1 minus 5 is going to be negative 4. Any questions on why we just did that? Okay. Next, what do we have to do? Divide by 2. And when we're dividing, we have to do every piece again. So this is y. Over here, we divide each piece by 2. So that equals 4x divided by 2? 4 over 2, which can be simplified to just 2x. Right? 4 over 2 would work out the same. You go up 4 over 2 is the same as going up 2 over 1. That works just right. Negative 4 divided by 2? Negative 2. So over here, we're going to start at negative 2 right there. And from there, we're going to go up 2 over 1. Or if you went up 4 over 2, you'd end up there. It would be the same line. Yep, 4 over 2 would be the same. Okay. Well, now we're going to complicate it a little bit more. I'm sensing a little bit of pessimism there. I'm hurt. Okay. I don't show it till I go home and cry myself to sleep at night. So anyway, this one gets confusing because both x and y are on the same side. And we are so used to solving for x that it's hard to get our focus away from it. But when we're going to graph an equation, we are trying, what we want to solve for is y. So I want to solve for y here. So I'm not worried about the x. The x is just another symbol. It's nothing to do with what we're going to do with the equation. So solving for y, again, we find our equal sign, just like we always did when we're solving, and we identify which side has the y. It's over there. We have to get rid of everything else but the y. So we look at what's been done to build this. Y has been multiplied by 2, and then the 3x was added to it because it's a positive 3x, right? The x is just part of that number. Remember, it's just like 3 inches or 3 cows or whatever. It's part of that number. So when we go to solve this, the first thing we have to get rid of is the 3x. It was added, so we're going to subtract 3x. It is now gone, leaving us with just 2y. But when we add or subtract, we do have to do it to both sides. We just only have to do it to one piece on each side. Over here, there is only the 6. What is 6 minus 3x? 6 minus 3x. Trick question. Can't combine them because they have different names. So 6 minus 3x is just 6 minus 3x. Now what do we have to do? We divide by 2 to get rid of the times 2. So that leaves us with just y here. Over here, 6 divided by 2 is 3. Negative 3x divided by 2 is negative 3 over 2x. So where do I start over here? I start at positive 3 up there. And from there I go down 3 over 2. Good. Even though it's the second number, the negative 3 over 2 is the slope because it is multiplying the x. I want you to try this one, see how it comes out in your notes. So, what's step 1 here? Subtract the 4x. Very good. So we're left with just negative 3y. What's 3 minus 4x? 3 minus 4x. Good. And then divide by a negative 3, giving us y equals -1. Yep. Well, -4 over -3 would be a positive 4 over 3x. So we're going to start where? -1 right there. And from there we're going to go up 4 over 3. Just like that. You guys want to try one more of those? Sure. Why not? What's it gonna hurt, right? What's different on this one, by the way? There's y on both sides, so the first thing you gotta do is get rid of the smaller one. So I already gave you the hint that we're going to start by getting rid of one of the y's. So I'm going to get rid of the smaller one, which is the 3y. So I'm going to subtract 3y to make it go away. That leaves me with just -4 on the right side of the equation. How many are with me so far? Lost you already? No? Okay. So now I have to subtract 3y on the other side. The only place I can take it from is the 5y. Remember, when we add or subtract, we only have to do it to one piece on each side. So the 3x is not affected. 5y minus 3y is a positive 2y. Now what do we need to do? Careful, we're going to step ahead. We're going to subtract the 3x. The 2 is multiplying the y, so we got to get rid of it by dividing, but that'll be the last thing we do. So we're left with a positive 2y equals -4 minus 3x is just -4 minus 3x. Remember, when you look at this, you have to ask yourself, if y were a number, the first thing that would happen to it is multiplying by 2, and then the 3x would be added. So when you take it apart, you've got to reverse that. You take off the last piece first. So the 3x had to go first. Now we would divide by the 2, giving me y equals, I have to divide each piece by 2 over here. -2 minus 3 over 2x. Good. And we start at -2, and from there we go down 3 over 2. What do you think? Better than a sharp stick in the eye? Maybe? For now? Okay. We've done worse, right? Well, since we're on the topic of graphing, I want to look a little bit at some graphs that you're probably a little bit more familiar with. We're going to start talking a little bit about data and displaying data. And one of the first steps in dealing with data and statistics, I know I said a bad word, is being able to organize it and simplify it graphically. Now, one of the things that we're not going to get into too great a detail in this class is starting out with the raw data. You know, if I were to go through and, let's say I'll go through and ask for the favorite color from each of my students in all of my classes from spring. And I might have, give them a choice between red, blue, green, and black. I'll just go red, blue, and green. How's that? So I might have responses of red, red, green, red, blue, blue, green, 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 red, blue, blue, green. I said blue and I put down red, but it's okay. Blue, blue. Let's see what I have. 1, 2, 3, 4, 5, 6, 7, 13, 14, 15, 16. So we'll go blue and red. Red, blue, red, red, red. Green, blue, green, green, red, green, blue, green, blue, blue, red, blue, green. Now, I just listed out 40 responses. Looking at that, without counting, but looking at that, can you tell me which one's the most popular? How many say that, just a show of hands, how many would say that red looks like it's the most popular? How about blue? How about green? How about no clue? Okay. A little quirk of the human mind is the human mind can only take in about, depending on your mind, between 7 and 13 things at once. That's one reason, by the way, that original phone numbers were 7 digits long. Because your short-term memory can take in that amount of things. This all depends on where you look at it. If I look right here, if I'm looking at this end of the data, it appears that what color is way, way more popular than the others? Red. If I look at this section of the data, it appears that it would be green. If I'm looking at this section of the data, it appears to be blue. I did that on purpose. Now let's actually list these out. What I'm constructing here is something called a frequency table, where I'm going to list out what it is that this is categorical data, so the response puts you into a category. There's two types of data, categorical and numerical. What I'm dealing with in every case is I'm asking a question. Here I asked, what's your favorite color? So your answer puts you into a category, the category of people that prefer red, blue, or green. If I asked you, what's your height? That would require the answer to be a number, so that'd be numerical data. Or if I asked, what's your GPA? Those are numerical. Normally, a frequency table lists the different possible responses, in this case the color categories, and then a frequency. But I'm going to add an extra column to this. It's just a working column. If I were presenting this graph in a report or for a presentation or something, I would leave this center column out. It's the tally column. So I've got 1, 2 reds, a green, a red, 2 blues, 4 greens, a red, a blue, a red, a green, 3 blues, a red, a blue, 3 reds, a green, blue, 2 greens, a red, a green, blue, green, 2 blues, a red, a blue, and a green. How many of you would have guessed it was going to come out that close? Yeah. It came out, what did I end up with there? 36 responses? Exactly the same. My frequency in all of them is 12. I was trying to get it close, but I didn't think I was going to end up exact. So I just got lucky there. You can see the deceiving nature of raw data because your mind can only focus on a portion of it at a time. That raw data, depending on where your mind happened to focus, it was very obvious to you that one was more than the others, and they turned out to be exactly equal. So I can organize categorical data with this frequency table. I can also organize numerical data, but it's sometimes a little more difficult. Now, one thing that I'll often do with this frequency table is I will put down something called a relative frequency, or sometimes something called a percent frequency. And in categorical data, the percent frequency is usually more important, but I'll show you how we do it. To do those, the first thing you got to find is the total. Here the total is 36. So the relative frequency would be found by taking the raw frequency divided by that total. So that'd be 0.333, right? Well, in this case, all of them are 12 for the raw frequency, so 12 divided by 36 would give us the relative frequency for each of them. This should add up to 1 or very, very close to 1. Ours adds up to 0.999, but that's because we had to round them off. If it was like 0.992, then we'd have to go back and look. Something like that would be a little sketchy. Percent frequency is just moving the decimal point to make it a percent. We know that 0.333 is 33.3%. If I wanted to, I could list it as 33 1/3% to make it exact. Again, this should come out to be really close to 100%. We have 99.9% if I add ours up, which is really good. So categorical data is easy to deal with. Numerical data, we have to split it up into two different categories. Numerical data can either be what's called continuous or discrete. There are a lot of different definitions out there for continuous and discrete. Discrete, and one of the technical definitions is separated, that there isn't a bridge from one number to the next. The numbers are separate. Continuous, one of the technical definitions, is no matter how close two data values are to each other, it's always possible to find one that's in between them. The simplest definition, the one that I use, is discrete data is data that can be counted. How many kids do you have? You can count those. How many cars are parked in your driveway? You can count those. How many people live in your house? Hopefully you can count those, right? Continuous is something that has to be measured. Your height, you have to measure that. Time is continuous, it's measured. Weight is continuous because it's measured. You look at those things that I said for measured, like height. There are no two people that are exactly the same height. If you go down to a small enough unit of division, you can always distinguish between the heights of two people. And no matter how close together they are, you can always find one that's somebody who's in between their heights. That's, all those different definitions of continuous come into play there. But we're just going to talk about counted for discrete and measured for continuous. So if I'm looking at continuous data, is the easiest to organize. If I'm trying to make a frequency table, let's say I'm going to list the number of cars that are sitting in your driveway and their frequency. And so let's say we got some people have 0, 1, 2, and 3 cars. So at this point, nobody that we surveyed had more than 3 cars. Well, it's pretty simple to say, hey, there's 0 cars. There were 8 people that had 0 cars in their driveway at that point. 1 car, there were 34 people that had 1 car in their driveway at that point. 2 cars, there were 49 people that had 2 cars in their driveway at that point, and 9 people that had 3 cars in their driveway at that point. Now you could do a percent frequency or a relative frequency with these as well. It would require us to add these up to get a total. If I add them up, what do I have? 42, 81, 90, it looks like. So then my relative frequency here would be 8 divided by 90, which is going to be 0.0889. 34, but what's that? Is that right? Is it 100? Oh, cool. It does add up to 100. Good deal. Oops. Well, that makes these divisions a lot easier. So 8 divided by 100 is 0.08. 34 divided by 100 is 0.34. 49 divided by 100 is 0.49. And 9 divided by 100 is 0.09. And I could change those into percents if I wanted to. On the other side of it, for measured, for continuous data, let's say I want to do heights. Most often when you're dealing with continuous or measured data, you cannot just list individual values like this. This is what's nice about discrete, is it's just like doing categorical. You just list all the values and you write down the frequency. Measured data or continuous data, you usually have to group it. For example, I can't list every possible height that everybody responded, but I might do 60 to 62.9 inches, assuming that I'm only measuring to the nearest tenth of an inch. And 63 to 65.9, and 66 to 68.9, and 69 to 71.9, and so on. And I have to list those. Now you'll notice I was very careful here to make sure that each of these is exactly the same size. From 60 to 62.9 is 2.9. From 63 to 65.9 is 2.9. All of them are 2.9 inches wide. The other thing I did was I made sure there's no gaps in between them. If I'm only measuring to the nearest tenth of an inch, there's no way somebody can fall in between. If I'm measuring to the nearest hundredth of an inch, this isn't going to work, because somebody who is 62.93 inches is going to fall in between here and here. It'd fall between groups, between classes. We're not going to do much of this just because this gets kind of tough to do these. We're going to stick with categorical and discrete numerical for the most part for what we're going to do. But just be aware that there is data like this. But even here, grouping it, if I just listed out numbers just like I did with the colors, it would have been really tough to pick out which one was more, one car or two. Sometimes it's obvious that some of them wouldn't be the most, because the 0 and the 3 would be pretty obvious to see that there's less of those. Okay, it is time for our break, so let's go ahead and do that. It is 10 o'clock. We'll come back at 10:10.